Some of you might be as unlucky as I was with my Ryzen 9800X3D CPU. Right after the installation I tried PBO-20 and it failed on the first stability test. I also tried -15 and it was working for a while, then it failed and I was like, okay, can it actually sustain any kind of PBO without crashing? Gladly I was able to find this thread on overclock.net where there is a nice guide how you can undervolt your Ryzen CPU. And before I show how have I implemented this guide, I want to show you some benchmarks stock against the PBO. In Cinebench 2024 on stock this CPU was running on 95 degrees Celsius, which to me is quite high temperature considering that my cooler is Arctic Freezer 3360 with 3 Fantex T30 fans, and I also happen to use PTM 7950 as a thermal compound. Comparing this stock amount against the PBO, we can notice that the difference is almost 20 degrees Celsius. Also power consumption is around 29 watts less for the PBO. Interestingly, also the score is quite the same across the board, so I would say that with PBO we are actually not losing anything whatsoever, if not gaining more. And adding additional 200 MHz to the PBO, we are basically just cancelling everything we have achieved with the PBO. For example, the maximum temperature is 13 degrees more over the PBO without the overclock, and also power consumption is around 31 watts more. In 3D Mark on stock, the CPU was running on 93 degrees Celsius. On PBO it was 11 degrees less, which means 82 degrees. Also the power consumption was almost 35 watts less for the PBO. Again, adding additional 200 MHz to this CPU has risen the temperature by 5 degrees. And yet we barely got any kind of additional points whatsoever. Of course, if you are after some records and competition, then in that case every possible megahertz you can squeeze out of your CPU is for the better. But for 27 usage I would say that PBO would probably be the best of both worlds. In Cyberpunk 2077 on stock this CPU was running on 82 degrees Celsius, while with the PBO it was running only on 70. 12 degrees difference in the same game with pretty much same FPS whatsoever. I would say that this PBO is definitely worth checking out. Adding additional 200 MHz, as we can see here, has changed the temperature from 70 up to 88, which means 18 degrees more temperature with pretty much no additional performance whatsoever. To me, this is also a good example that adding these 200 MHz is simply just not worth it. So my first step during this Undervolt procedure will be that we update motherboard's BIOS to the very latest beta version if it is available and if it's newer than the official version, because more often than not these beta versions also include the very latest AGISA version, which includes a lot of different stability improvements and fixes, and that is extremely important during these stability tests. Once the BIOS has been updated, I want to enter on the advanced mode here and then go down to AMD overclocking, Precision Boost Overdrive, and I want to select advanced. Here we have a couple of different settings, and more often than not it is said that these PBO limits should be set on motherboard, but at least in my case I have noticed that motherboard limits are basically unlimited, because these limits are set on value 1000, and in this case that means that the motherboard will allow up to 1000 amperes limits, which to me is just simply silly. So instead of that I want to leave this on auto, and I will tell you in a bit what else I'm gonna do regarding these limits. Precision Boost Overdrive scalar control, I want to set this on manual and I want to set it to 1x. Basically what this does is that it will more aggressively push your CPU to the higher frequency, which means higher voltage, and it will sustain there for a bit longer time. According to some information, 10x can degrade your CPU over time, but unfortunately I don't have any kind of data to support that. And I personally want to be on the safe side, so I will leave it on 1x, but of course you can experiment for yourself if you find it to be valuable for you. And this CPU boost clock overdrive I want simply to leave on disable, because to me, as we have seen on those benchmarks, it's simply not worth it. And platform thermal throttle control I want to set on manual, and instead of 95 I want to set it on 85. This means that whenever this CPU hits 85 degrees, it will throttle down, because I personally do not believe that we are gaining much of any extra performance past 85 degrees. But of course, in this case as well, you can experiment for yourself if you find it to be useful for you, for example, 90 or 95 degrees. But for me, 85 is kind of a sweet spot. And this will also reduce these PBO limits as well. So in this case, this thermal throttle will basically do the heavy lifting for us, so we don't need to touch these PBO limits whatsoever. In this case, I think CPU will be limited up to 162 watts, which to me is much more better limit rather than having everything on 1000. Moving to curve optimizer, I want to leave it on disable, because at this point we want to see what are the stock values before we start adjusting these offsets. So let's go and save this BIOS and boot into Windows. So now when we have booted into Windows, I want to represent you 5 different tools what I have used for this purpose. First tool in question is obviously Hardware Info 64, which I'm sure is familiar to many of you. We need this tool to be able to measure these voltages while we are adjusting them. The second tool in question is Status Core, where we will be able to generate the load per single selected core in order to measure the voltage per single core. And the third tool in question is SMU Debug tool, which will allow us to adjust these PBO offsets per single core on fly rather than adjusting them on BIOS and have to reboot every single time we want to do any kind of changes on this. Fourth tool in question is Y-Cruncher. I think Y-Cruncher is great because it will tell us in case we have a couple of cores unstable, so that we can do fine-tuning at those cores until we have every single core stable. I would say with Y-Cruncher we will need to run it probably about 20 or a bit more cycles in order to be quite sure that we are having a stable CPU. And the last but not least tool in question is Ada64. I want to thank Ada for sponsoring me with the license for this video. However, I wasn't asked to say anything in particular. Ada is great because it is one of the most brutal, or should I say sensitive, tests for Ryzen CPUs at the moment, because I've read so many different stories where the CPU was totally stable on -30. The moment you start running Ada, you're getting failed results whatsoever, which means in other words that CPU is definitely not 100% stable. And you are totally fine with this Ada trial version, because I'm sure most of you will just basically adjust these Undervolt settings and basically forget the whole thing, which is totally fine. But in case you find this to be useful, please consider buying this software and supporting the company behind this, because I definitely think that we need more software like this one in the future as well. So let's get started with this procedure by actually measuring the default voltages per single core while we generate a load per single core. For that, I recommend you to take notes, because we will need to have actual information what was the default value, and upon that we need to harmonize the voltages based on the best cores we have available on this CPU. And in Hardware Info, some of you already know that you are able to see what are your best cores on your CPU. This will be different from the CPU to CPU, so please do not take this information for granted if you are comparing this my Ryzen 9800X3D against yours. Your CPU's best cores might be totally different than on this CPU in particular. So before we start measuring any voltages whatsoever, we need to do a couple of changes in Hardware Info in order to get a better picture what kind of voltages we are talking about in one particular situation. So for that we need to click on this cog configure sensors, and we need to adjust this global polling period down to 250 milliseconds. We need to click set. Then we need to go down and click on main settings here and enable this snapshot CPU polling, which is obviously, it will take a snapshot picture of our CPU values. So let's start generating load on core number 0, which is the first one on the list, and see how it goes. I'm gonna click thread number 1 over here, and we need to remember to reset those values in order to get the best reading. And we want to focus actually on this CPU VDD CR VDD voltage, because this is the one what is actually happening right now. And these VID voltages over here I have highlighted are the voltages what actually CPU is asking motherboard for. The voltage down below is the one actually provided to the CPU, so this is the one we want to focus on. Down below you can see the power package consumption, but that's not the case in this particular situation. So core number 0 is actually getting around 1.180 volts. And for this measurement, I recommend you to run it probably for approximately 30 seconds. And after that, we need to actually take a note of this maximum value. So in this case, I'm going to write down 1.180 volts. And then we can move to core number 1 here. In this case, we need to enable thread 3 because every single core obviously has 2 threads. So we need to select core rather than thread itself. So this is the core number 1. And I'm gonna reset these values so we can see what's going on over here. And it's getting 1.168 or something. I will write it down. But let's wait a bit and see will it change over time. As you can notice, actually this core is requesting much less voltage rather than core number 0. And that's totally true, because if we check this list over here, we can see that core number 1 is listed as the best core of this CPU, also with the core number 3. So that also explains why the voltage is lower compared to the core number 0. And it definitely looks like it's 168 over here. Then we can move to core number 2, and in that case that's thread number 5. In this tool over here, please pay attention that you're selecting right cores, and you can always check the activity graph over here. So you need to select basically every second number on the list here. And now we need to reset these values to see core number 2 doesn't look that good actually. It's 1.187 volts. I'm gonna do the rest to keep this video short enough, but I'm sure at this point you get the idea about this. So now when we have measured every single voltage per core on the first run, which means on the stock voltages obviously, we need to focus on harmonizing these voltages against the best core, which in this case is core number 3. And now we will actually need to adjust these PBO offsets on the fly and see how close we can get to this core number 3 voltages. So let's get started. And for that, I'll recommend you to take another set of notes, let's say test version 1, and we need to measure all these voltages again. I'm just gonna empty all this information here not to confuse us. And now we actually need to aim with core number 0 to reach out this 1.156, 1.160. And let's select core number 0 over here. So we are generating the load, and now I need to do the offset and see how low we can go with this. Please pay attention on this voltage because it will change on the fly as soon as we click on apply here in this Ryzen SDD tool. If I set -3, we can notice that it is definitely lower, because once I reset the value, it shouldn't reach out 1.180 volts. So we are quite similar to the Core 3. I would say this is quite a good guess, if anything. So 166, maybe there is a bit of a room for improvement. Let's try -4 and reset the settings. In this case as well, I recommend you to wait from 30 seconds up to 1 minute per single core in order to get a quite solid picture what is the maximum voltage you are getting from that particular core. And again, we need to take some notes. So at this point, we will have to say this, and magnitude is not 0 but -4. And let's move to core number 1. we have to reset values and see what we are getting actually with it. Obviously that's a very good core as it is listed over here. It's a number 1, and let's see, it's quite close to core number 3, so at this point I probably wouldn't touch it before we are basically going below this voltage down the line. So let's go and do the core number 2 next and see what is going. Okay, let's try -3 and see. I'm gonna reset the values. So yeah, it's too high. Let's go a bit lower. Maybe one more, -5. Let's see, will it be okay? Yeah, it looks much better. And we should wait probably for 30 seconds, but I'm gonna write this down during this measurement time. So core number 2 offset -5, and the maximum voltage is 1.158 volts. I'm gonna repeat all of these things again to keep this video short enough, so see you in a bit. So now I have measured actually the first run of these offsets, and we can notice that all these voltages here are extremely close to each other compared to what was the starting point of this. And now I recommend you to actually apply these values in your BIOS under PBO settings per core, and try to run Y-Cruncher for approximately 20 iterations to see whether your CPU is stable or not, because Y-Cruncher will tell you in case you have one of these cores to be not that stable after all. You can do a fine tuning by actually giving it a bit more voltage, which means you just adjust these offsets to a little bit higher and see will it work out for you. But once Y-Cruncher has been stable for you, we can continue actually lowering these voltages before we move to AIDA64 tests and have those 10+ hours stability tests running. So let's do another set of these measurements actually next. And I also recommend you to take notes, because you will actually see how much you are actually advancing in this. And at this point, because all these voltages are basically already close to each other, so what should we do next? In this case, I recommend you to maybe try -0.03 or maybe -0.05 voltages. And what I mean by that is that we need to basically select core number 1 here, and let's see what's the actual voltage of it right now. So it's 1.155 or 1.6 or whatever. So let's try to lower it to 1.13 in case we can have that. Let's see, will it be there? Something like this, I would say, -10. And now let's reset the measurement. We can see 1.132, and this is basically something that it might be worth testing out in case your CPU is stable with these voltages. So let's say the core number 0 is -10. Then let's go to core number 1, and at this point core number 1 won't be as good as it was previously, so it means that we need to lower this voltage in order to hit that 1.133. Apologize, I need to measure these voltages. As you can see, I'm also making mistakes on this, so please be careful and take time with this. I know it's a quite slow process, but once you do it, I'm sure many of you will be much more happier rather than going and replacing your whole CPU. So okay, so 1.137, and let's run it for 30 seconds. I'm gonna speed up this video now to keep this video as short as possible. So after the second run, we can notice that we actually have at least 4 cores on -10, and this is basically just telling us that these cores are definitely different from each other. And this is kind of a way how we can also go even further than this, but at this point I recommend you to run Y-Cruncher for that 20+ iterations and see is your CPU stable or not. Of course, you can run AIDA64 at this point and see will it fail or not, but nevertheless, in case you don't want to, we can of course continue and try to get even more advantage of this undervolt. At this stage, maybe going down deeper to maybe 1.12 or 1.1 voltage in case we can hit that amount. And obviously it's gonna be repetitive procedure as previous one, so we need to load again core number 0. We need to follow this voltage over here, it's 1.131. And what happens if we set like minus 14, it's gonna 1.16. I can give it a bit more. Let's go by 2, like 0.15 or something. And this can also be a great advice as well, that we are basically doing -2 magnitude on every single core and see how far we can go with it. So obviously this was -10 in the previous run, now we are doing -12 and the voltage is approximately 1.25 or something. This can actually be the kind of final voltage for some of you, but I strongly encouraging you that you try and see how far or how low you can go with these voltages with your CPU. And now let's try core number 1 to see how much we can lower it. Can we go by 2? Yeah, I think this can also be going by 2 actually. -6. And basically you can do the rest for yourself, but I'm sure that at this point you get the point. And after this third run, I strongly recommend you to run that AIDA 64 for that 10 to 15 hours overnight probably, so that you know for a fact is your CPU stable at these magnitudes or not. And of course I recommend you to actually apply these magnitudes in your BIOS, then start up the Windows and run AIDA 64 without actually having much going on in the background. And I'm sure AIDA will tell you the story the longer you run it. But please pay attention that the ultimate goal is that you're having Y-Cruncher 20 plus iterations stable plus AIDA stability in 10 to 15 hours at least. So you have to have both of these tests actually without fails in order to be confident that your CPU is actually stable. And obviously you can continue to run up to maybe 4 or 5 different iterations and lowering these magnitudes as low as you can possibly go, but it's totally up to you. But even with this, I would say it's much better than running everything on, I should say, -10 or -5, because even at this point we are still saving some power and having our CPU cooler rather than having that minimal level of undervolt. And I just wanted to show you my personal notes I took while doing the undervolt for my CPU, and you can see basically that I was able to go as low as this one, and now you can see what kind of voltages I was getting with my CPU. But please notice that there will be difference from CPU to CPU, so your CPU might actually go even lower than this one. Unfortunately, I tried to go even deeper than these values and I was failing in AIDA, as you can notice over here. So this is pretty much the kind of ultimate limit of my CPU, I would say. And even then, I would say these magnitude values to me look much more better than just slapping -10 on it and call it a day, right? But it's totally up to you how much you want actually to test it out with. Hopefully this video has been informative to you. My name is Leo and I will see you in the next one. Bye bye.